Welcome to Educator.com. In today's lesson, we'll be discussing the rational zero theorem. What this theorem tells you is the possible rational zeros of a polynomial. And again, it just helps you generate a list of possibilities. So if f of x is some polynomial function with integer coefficients, then you can generate a list of possible rational zeros by looking at two things: the leading coefficient and the constant. Okay, so if p over q is a fraction in simplest form that is a zero of f of x, then p is a factor of a sub 0, which is a constant, and q is a factor of a sub n, which is the leading coefficient. So let's think about what this is saying. P over q. Here, p is a factor of the constant. So the numerators of all the elements of the list that we're going to generate consist of factors of the constant. The denominators can consist of factors of the leading coefficient. Using this equation, using the rational zero theorem, what I can do is make a list of the factors of the constant, make a list of the factors of the leading coefficient, and then find all possible combinations using those factors as the numerator, the factors of the constant, and the factors of the leading coefficient as the denominator. Find all the possible combinations, and then that'll give me a list of possible rational zeros. Now, this is only a list, and we're going to talk about how you check the list and determine which ones, if any, are actually zeros, because it may turn out that none of these are zeros. It may turn out that the zeros are irrational or complex, that the roots or zeros are irrational or complex numbers. But if there are rational zeros, they'll be members of this list. Okay, using an example, f of x equals 4x squared plus x minus 3. Here, my leading coefficient is 4, and the constant is 3. Now, I'm going to first just think about the factors. So the factors of 4 are going to be 1, 2, and 4. And these could be positive or negative, and I'm going to worry about the signs in a minute. Right now, I'm just going to look for the factors. The factors of 3 are 1 and 3. Now, these factors of the leading coefficient are going to comprise the denominator. So these are possibilities for the denominator. Here, these factors of the constant are going to be possibilities for the numerator. So I'm going to take each one, I'm going to go in an organized manner. I'm looking for different possibilities for p over q for the factors of 3 over the factors of 4. P over q could be, I could have 1 in the numerator and 1 in the denominator. And it could be positive or negative, because the factors here can include, it could be -1 times -4, that would give me 4, and so on. So I could have all different combinations, positive and negative. Okay, I could have 1 for the numerator, 2 for the denominator, plus or minus. I could have 1 over 4. Okay, I could have 3 over 1, plus or minus. I could have 3 over 2, plus or minus 3/2, and plus or minus 3/4. And then just writing this simpler form, this is just plus or minus 1, plus or minus 1/2, plus or minus 1/4. This is just 1. This is just 3. 3/1 is just 3, plus or minus 3/2, plus or minus 3/4. So this gives me the list of possible rational zeros. Now, let's factor this out and see what happens, just to check and make sure that what we come up with actually is on this list. So let's take the corresponding equation and find the zeros. 4x squared plus x minus 3 equals 0. And you can actually factor this out. And this is going to come out to 4x minus 3 times x plus 1. So this would be 4x squared. And this would be 4x minus 3x would give me x. Negative 3 times 1 is negative 3. Using the zero product property, I'm going to get 4x minus 3 equals 0. And x plus 1 equals 0. So this is going to give me 4x equals 3 or x equals 3/4. This will give me x equals negative 1. I look and I have 3/4 on the list and I have negative 1 on the list. Both are on the list. So what this gave me is a list of 1, 2, 3, 4, 5, 6 possibilities, positive or negative. That's 12 possibilities. And I found 2 of them. I was able to find this by factoring. But so what it's showing is that these were on the list. But again, this is just a list of possibilities. And you need to be able to figure out which possibilities are correct. So what we're going to do is generate lists of possibilities and then talk about what you can do with that information, how you can find which possibilities are correct. Okay. If the leading coefficient of the polynomial is equal to 1, then the rational zero theorem tells us that any rational zero of f of x is a factor of the constant. Okay, let's think about what this means. So we said that the list of rational zeros equal p over q, where p is factors of the constant, let's just say the constant, and q are factors of the leading coefficient. Well, if the leading coefficient is 1, then this becomes p over 1. So it's just going to be the factors of, which is just going to be the factors of the constant. So in the situation where the leading coefficient is 1, you just have to look at the factors of the constant, and those will give you your list of possible rational zeros. For example, if I have f of x equals x to the 4th minus 3x cubed plus 2x squared plus x minus 8. I have a leading coefficient of 1, so I don't need to worry about that. P over q equals p over 1 equals p. Now, here, p is going to equal the factors of the constant, which will be factors of 8 equals plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now, I mentioned that these are just possibilities, so I need to check these. And if you'll recall, we can check to see if something is a factor by using synthetic division. So we also talked about how if a number is a 0, then if you take the value of the function, you're going to find that if f of a equals 0, then x minus a is a factor. So, for example, if x minus 2 is a factor of f of x, then f of 2 will equal 0. And recall that using synthetic division, we can find the value of a function by looking at the remainder. So what we can do is go back to synthetic division, or synthetic substitution we call it in this case, and divide the polynomial by x minus a, where a is one of the factors we're checking. And if the remainder is 0, then we know we've got a factor. So, or a rational 0 in this case, if the remainder is 0. Okay, so these factors are also zeros because f of a is 0. So if I go ahead and I divide, for example, f of x by x minus 2, that will allow me to check to see if 2 is a factor. If 2 is a factor, the remainder will equal 0. So let's go ahead and do that. Here we're dividing by 2, and I do not have any missing terms. So I have coefficient of 1, coefficient of -3, coefficient of 2, another coefficient of 1, and coefficient of -8. Bring down 1, multiply 1 by 2. That gives me 2. And now I take 2 plus -3 to get -1. Multiply -1 times 2 to get -2. Combining 2 and -2, I get 0. 0 times 2, 0. 1 plus 0, 1. 1 times 2, 2, to give me a final value of -6. This is the remainder. So 2 is not a 0 of f of x. If the remainder here was 0, then this would tell me that 2 is a 0 of f of x because it's telling me that f of 2 equals 0. In other words, when x equals 2, the function equals 0, and by definition, that's a 0. It's crossing the x-intercept. Okay, to sum up, if you're looking for rational zeros, list all possible rational zeros using the theorem. And the theorem says that P over Q equals the factors of the constant over the factors of the leading coefficient. Once you've done that, use synthetic division to determine which possibilities are actually zeros. Division will yield a remainder equal to 0 if the value is a 0. So you get your values for P and Q, you take the function and you divide it by each of the values that you're trying, P over Q, and if remainder equals 0, P over Q is a 0. If the remainder is anything other than 0, then it's not. So list the rational zeros and then use synthetic division to check. Okay, list all possible rational zeros of this function. So I need to find values of P over Q, and I'm going to first look at the constant. This is A0 equals 9, and the factors are 1, 3, and 9. So these are values for P. Here, the leading coefficient equals 2. Factors are just 1 and 2. Okay, so now I'm going to go through all these different combinations of numerator 1, 3, 9 and denominator 1 and 2. So possible rational zeros are plus or minus 1 over 1. So I'm just going to simplify that to 1 right away. Or plus or minus 1/2. Next, plus or minus 3 over 1, which is just 3. Plus or minus 3 over 2. Next, plus or minus 9 over 1, which gives me 9. Plus or minus 9 over 2. So I have 1, 2, 3 times 2, that's 6 possibilities. And then plus or minus for each gives me 12 possible rational zeros. I don't know which, if any of these, are actually zeros. I would have to check using synthetic division. Okay, in this next example, we're asked to actually find the rational zeros, not just to list the possibilities. So I'm going to need to use synthetic division. Since the leading coefficient is 1, then possible rational zeros equal the factors of 3. I don't need to worry about this. The denominator is just going to be 1. Okay, factors of 3 are 1 and 3. So my possibilities are plus or minus 1 and plus or minus 3. Now, I need to check these using synthetic division. So starting out with 1. And I'm looking, and there are no missing terms, x cubed, x squared, x, and a constant. So I can just go ahead and put these coefficients, 1, negative 2, negative 2, negative 3. This is 1 times 1 is 1. Combining that with negative 2 to get negative 1. 1 times negative 1 is negative 1. Plus negative 2 is negative 3. Negative 3 times 1 is negative 3. This is negative 6. Remainder equals negative 6, so 1 is not a 0. Okay, now let's try negative 1 right here. Again, my coefficients are the same, 1, negative 2, negative 2, negative 3. Okay. This is going to give me 1 times negative 1 is negative 1. Negative 2 and negative 1, negative 3. Negative 3 times negative 1 is 3. Combining that with negative 2 to get 1 times negative 1. And that gives me negative 1 and negative 3, and this is negative 4. So this is not a 0. Okay, next possibility, 3. So let's try 3. Coefficients 1, negative 2, negative 2, negative 3. This is going to give me 1 times 3 is 3. 3 and negative 2 is going to give me 1. 1 times 3 is going to give me 3 again, and negative 2 is going to give me 1. 1 times 3 is 3. 0. 3 is a 0 because the remainder equals 0. 3 is a 0. Okay, I found one rational 0. I have one more possibility left. I checked 1, I checked negative 1, I checked 3. Now I need to check negative 3. 1, negative 2, negative 2, negative 3. Bring down the 1 and multiply by negative 3 to get negative 3. Combined with negative 2 gives me negative 5. Negative 5 times negative 3, that's 15. Plus negative 2 leaves me with 13 times negative 3 is negative 39. And that's negative 42. So this is not a 0. So the rational 0 for this function is 3. 3 is a rational 0. I had this list of possibilities, and the only one that turned out to be correct, an actual 0, is 3. Okay, list all possible rational zeros of this function. So I'm going to be looking for P over Q, which equals the factors of the constant over factors of the leading coefficient. So what this is going to give me is 15 1, 3, 5, and 15 over factors of 4. 1, 2, and 4. So I need to figure out all these possibilities and use positive and negative for each. So 1 over 1, that's plus or minus 1. And then 1 over 2, plus or minus 1/2. 1 over 4, plus or minus 1/4. Okay, now going on to 3. 3 over 1 is just plus or minus 3. 3 over 2, plus or minus 3/2. 3 over 4, plus or minus 3/4. Okay, next 5. 5 over 1 is just 5. 5 over 2. 5 over 4. Okay, then 15. 15 over 1, just 15. 15 over 2. And then 15 over 4, plus or minus. So there's a lot of possibilities here, and I listed them all out, but if you were actually asked to find the rational zeros, you need to check these through synthetic division. Okay, here we're asked to find all zeros of this function, and notice it doesn't just say rational zeros, it says all zeros. But I'm going to start out by looking at the rational zeros. And since the leading coefficient is 1, the possible rational zeros will equal factors of the constant. And that is because if I'm taking P over Q and the denominator is the factors of the leading coefficient, here the only factor is 1. So I'm just going to end up with P. So factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. Now, I have a list of possible rational zeros, and I'm going to use synthetic division to determine which of these are actual zeros, not just possibilities. Coefficient here is 1. Coefficient here is 2, negative 2, and negative 4. Now, there are no missing terms. I've cubed, squared, x, and a constant. So I'm going to go ahead and use synthetic division. This is 1 times 1 is 1. So this gives me 2 and 1, which is 3. 3 times 1 gives me 3. Combined with negative 2 is 1. 1 times 1 is 1. Combined with negative 4 is negative 3. This is not a 0. 1 is not a 0 because the remainder is something other than 0. Let's try negative 1. Coefficients are again 1, 2, negative 2, and negative 4. Here I have 1 times negative 1 to yield negative 1. Combined with 2 is going to give me 1. This times negative 1, negative 1. Combined with negative 2 is negative 3. Negative 3 times negative 1 is 3. Plus negative 4 is negative 1. Again, this is not a 0. So not a 0, not a 0. Let's try 2. Okay. Again, same coefficients, same process. Bring down the 1, multiply by 2. Combine to get 4. 4 times 2 is 8. Plus negative 2 leaves me with 6. Times 2 is 12. plus negative 4 is 8. Again, not a 0. Now I'm going to try negative 2. Bring down the 1 times negative 2. Combining 2 and negative 2 leaves me 0 times negative 2. Combining, get negative 2 times negative 2 is positive 4. Negative 4 and positive 4 is 0. So, looking at this, since the remainder equals 0, negative 2 is a 0 of this function. Now, I could continue on to check these two, but there's an easier way to proceed. Because what this is telling me is that if remember, this is the opposite sign. It's telling me that x plus 2, because I took the opposite sign, is a factor of this. So that leaves me with x plus 2 times, this is x cubed, so times 1x squared, so x squared, plus 0x, so that drops out, minus 2. This is what I'm actually left with. X plus 2 times x squared minus 2. So instead of just checking these two, and they might be right, they might not be right, but what I'm going to need to do if these are not correct, because there's 3 zeros, because the degree is 3, is then I'm going to need to find irrational or complex zeros. So instead of bothering to even check these, I just use the fact that I now have x squared minus 2 times x plus 2 to go ahead and use factoring to solve. So I know that I've got x plus 2, and I look and I can't factor anymore. So I use the zero product property, and I know that already that x plus 2 equals 0 and x equals negative 2. I figured that out, but I can go on and do it with this as well. X minus 2 equals 0. And this is going to give me x squared equals 2. I'm then going to take the square root of both sides to get x equals plus or minus the square root of 2. So I have 2 zeros here, and I have 1 here. So the zeros are negative 2, square root of 2, and negative square root of 2. And this is an irrational number, so it wasn't on my list of possibilities. So it's easier to proceed by finding 1 0, and then using the information that you have here to write the factored out, or at least partially factored out in some cases, form of the equation, and then go on and use the zero product property to find the remaining zeros. Thanks for visiting educator.com, and I'll see you next lesson.